Hey there, and welcome. Have you ever stopped to wonder what all our amazing, super complex technology is actually, well, saying to itself? Today, we're going to pull back the curtain and take a look at the surprisingly simple language that powers, well, everything in our digital world.
I mean, think about it. It really does feel like magic, right? You tap on your screen and boom, almost instantly, a video from halfway around the world starts playing. How in the world is that even possible? What kind of secret code is flying through the air to make that happen?
Well, the secret is it's all just data. That cat video, the text message you just sent, the picture you posted, even the invisible signal your Wi Fi router is pumping out right now, deep down, it's all the exact same stuff, just packaged up a little differently. Okay, so how do our machines handle all this information? How do they tell the difference between a photo and a song? Well, they translate all of it into the absolute simplest language you could possibly imagine, a language that only has two letters. Just look at the difference here. Think about our own languages, right? We've got 26 letters, 10 numbers, and just an endless sea of symbols to get our ideas across. But machines? They boil absolutely everything down to just two little digits. It's, it's a wild level of simplicity, and you're about to see why that simplicity is its greatest strength. And that system is called binary. Yep, at the very heart of every single computer, every phone, every smart TV is the simple system that only uses two numbers, 0 and 1. That's it. The whole show runs on just those two. Honestly, the best way to wrap your head around this is to just picture a light switch. For a piece of hardware, a switch is either on, letting electricity through, or it's off, blocking it. There's no maybe, there's no kinda on, so we just assign 1 to the on state and 0 to the off state. It's a language that machines understand perfectly, instantly, with zero confusion. Okay, so a machine gets on and off. That's cool. But how do you possibly get from a simple light switch to a high-definition cat video? Let's break down how these two simple states are used to build up all the amazing complexity we see every day. So each one of those individual zeros or ones is called a bit. It's short for binary digit, and it is the absolute smallest piece of information you can have in the digital world. You can think of it like an atom. It's the fundamental building block of data. Now, a single bit by itself doesn't tell you much. It's just a yes or a no, an on or an off. But the real magic happens when you start grouping these bits together into long strings. Because a long string of them, well, that can represent literally anything. So what did these groups of bits become? Well, thanks to some globally agreed upon standards, a specific pattern like 0100001 becomes the letter A in your email. A different, much longer pattern tells your screen the exact shade of blue for one tiny pixel in a photo. And other groups form those really important network addresses, like your IP or MAC address, that let all our devices find each other and actually talk.
It almost seems too simple to really work, doesn't it? But, there's a reason this system has been the bedrock of computing for decades. It turns out there's a whole lot of power in just having two options. At the end of the day, what you want from any communication system is for it to be fast, reliable, and accurate. And the binary system, it totally nails all three, making sure that what one machine sends is exactly what the other one gets. And this isn't just some clever theory. It works incredibly well. Because there are only two states for the hardware to check for, communication happens at lightning speed. It's super reliable because the chance of mistaking a 0 for a 1 is practically 0. And of course, that reliability leads directly to accuracy. And that's really the key takeaway here. The reason binary is so unbeatable is its beautiful, perfect simplicity. Is there an electrical pulse? Yes, that's a 1. Is it gone? No pulse, that's a 0. For a machine, there's just no room for error, no space for confusion. It's either on or it's off. So the next time you're scrolling through photos or watching a video, just remember, it's all just a massive, super fast, coordinated blinking of trillions upon trillions of tiny little light switches, an entire world of nearly infinite complexity, all built on the simple foundation of a 0 and a 1. It really makes you wonder, what's the next profoundly simple idea that's going to come along and completely change